Morning, good afternoon, everybody, once again. Welcome to our webinar, U-zontal Wells, Seamless Communication between Geosteerers and Directional Drillers. I think we have a very good participation rate today, and we are just generally very excited to present this topic. Now, before we start, just a couple of organizational moments here. So you're all muted, and we'll keep it that way. But if you have any questions during the webinar, feel free to ask those questions in the chat during the webinar or after the webinar. We'll answer it either after, or if we feel that this question will be answered during the webinar, we'll probably just skip it, or if we still have that question after we finish, we'll answer that. Now, how we'll conduct it is basically we'll do a brief introduction. We'll introduce ourselves. Then we'll have just a couple of slides on the products. And then we'll do a live demo on how the integration works, and with some conclusions, and hopefully with some questions and answers session at the very end. That shouldn't take more than 1 hour, probably less than that. So with all of that, let's get started. So first of all, let us introduce ourselves. So my name is Igor Kuvaev. I'm Chief Technology Officer of ROGII, and we'll be switching back and forth. So Daniel, please go ahead.
Yeah, hi, I'm Dan. I'm the CEO of INNOVA Drilling Intervention, and we've been working with Igor and ROGII for about the last year now.
Awesome. So yeah, let's get started. So as I mentioned, we'll start with just a few slides. So then we'll start with presenting his solution, his software on directional drilling, and then I'll show what we have on the geosteering part. And because we have two groups together at this webinar, directional drillers and geosteerers, we'll cover some basic stuff about our products. So let's go ahead. So Daniel, please let me know when to switch the slides.
Yeah, okay, no problems, Igor. So yeah, as Igor said, I'm Dan. I'm the CEO of INNOVA Drilling and Intervention. We are a software technology company primarily catering towards the directional drilling space. Igor, if you could just move to the next slide. We've been going now for about the last 12 to 13 years. We started in 2011, and we've grown our operations to encompass 6 continents and operations in about 70 different countries. Right now, we are actively on well over 1,500 rigs globally, and we have got products which are used not only by directional service providers, but by operators, engineering companies, tool rental companies, and everywhere in between. Can you just move on to the next slide, please? So the product we're going to be talking about in today's webinar is WellSeeker Pro. This is our directional drilling desktop application. Most of you from the directional side of the industry will be very familiar with it, but for those of you who are not, WellSeeker Pro is the application which directional drillers at the rig can utilize for calculating well trajectories, making bit projections, visualizing the well, or running anti-collision, and is also used for all their sort of field reporting needs. And like I say, that's going to be the product which we're going to be demonstrating today. WellSeeker is integrated with the ROGII StarSteer and Solo Cloud platforms. And we're very, very excited to present this integration with ROGII today.
Very good. So let me do a quick introduction of StarSteer software and Solo Cloud that we'll be using for the demonstration today. So first of all, if you ever involved in literally any geosteering operations, any horizontal drilling operations anywhere in the world, most likely you were using or StarSteer software was used to geosteer that well. We are present pretty much in all the places these days where the horizontal wells for oil are, being drilled. And really, what we'll be using today is a desktop application, StarSteer, that is used by geologists to come up with the geosteer recommendations, and those geosteer recommendations are sent to directional drillers so we can stay in target. And later on during the demonstration, we'll briefly cover that part. So geosteering is a very big and broad subject. It can be conducted using fairly simplified set of data, say gamma ray only and survey data only. However, it could be as complex as running very sophisticated LWD resistivity tools, utilizing geomodels, utilizing seismic data, utilizing various tools to drill in a very complex geological environments. So in StarSteer, we support all of that. But really, mainly what we'll be focusing on today is the screenshot to the left, is a complex three-dimensional drilling in a typical US onshore environment where we're limited to gamma ray and survey data only. Now, the reason, one second, please. Slides are switching slowly here. The reason, how this entire integration was made possible is because all the data, when you're utilizing StarSteer and if you're connecting to a Solo Cloud environment, which is very widely used in drilling and geosteering operations these days, that information is available for third-party providers through a public API. Of course, as long as you provide your company's credentials to that company. And that's how WellSeeker Pro integrated with us, and we'll show it to you live how it works. So basically, whenever you introduce a change on StarSteer side, that change is pushed to directional drilling application, WellSeeker Pro, and the resulting well plan is pushed back to StarSteer, so we can verify that everything worked correctly. So once again, it's all possible when you're utilizing Solo Cloud, and it's a very quickly growing product solution cloud environment. At the moment, we are hosting about 1 million wells on Solo Cloud, and roughly 300 operators are using it to store the data. So with that, Daniel, let's switch to the demo, right?
Perfect. Sounds great, Igor.
So let me open two applications here side by side. So on the left side, we have StarSteer, and maybe let me give you a quick introduction on what we're dealing with here. So this is a single U-shaped lateral, and how we'll demonstrate it to you today is we'll be basically simulating live real-time drilling by by adding the data to this well as we drill. And of course, this well is not, it has been drilled already, but we'll show you different parts of the well, how we can communicate with direction drillers and geosteerers during the drilling of that section of the wellbore. So we'll start by looking at this portion of the lateral that has just landed. So as a quick introduction, this is a Chesapeake well, Chesapeake U-shaped lateral drilled in Eagle Ford a couple of years ago. So it's the real data, but we're kind of simulating the real-time drilling of that well. And you can see the shape of the well plan on the map view here. So it's a U-shaped lateral complex 3D well. And the well just landed, as I said. And here on the cross section, we can see the entire well plan in yellow, and we can see the landed portion of the lateral in blue. Now, few introduction points, which are quite important for the entire presentation flow. First of all, even though it's a U-shaped well, you can see the entire well plan in front of you. And the reason why it's possible is because we are using so-called a THL scale, true horizontal length. In a simple words, it's a curtain section. So if I'm to display this well in vertical section, basically the well plan is going to overlap on itself because it's going forward and then it's going then it's going backwards. But really for such a complex 3D shaped lateral, I would like to use a THL scale. So this is kind of number one component on drilling such a complex lateral wells. Second thing, we'll do the targeting. We'll do the basically directional drilling recommendations using target line tool here. So my target line is visualized in green here. And I can go ahead and edit my target line based on my geosteering recommendations here. And we'll talk about it a bit later, but I have multiple target lines, and this is the one that I would like to use, which is start target line. Another thing, which is also important to mention, I have a so-called geosteering interpretation here, which is kind of outlined as white or lighter color, and not going into super details on how geosteering is conducted, but basically this is what geosteering geologist is constantly doing. He or she is adjusting or analyzing the gamma ray that we're receiving in real time and interpreting this well. And the result of the interpretation is this geosteering model, basically whether we are in the target or outside of the target and how far away we are from the top and base of the target. So I'm receiving this gamma ray data in real time, and I am coming up with my geosteer interpretation. And once I have my geosteer interpretation, I can put my target line into the desired part of my formation. So basically I can recommend to the directional driller to go up or go down or to follow certain target lines. And of course, I have my projection of my geosteer interpretation. So this is how I expect it to behave as we drill ahead. However, geology is uncertain. This is the reason why we we geologists constantly introduce changes to our target lines, because yes, we expect certain geology, but as we drill, the geology is changing, and we need to change the target line. We need to change our geosteer recommendations. The last thing I would like to mention in this introductory part is that target line. So you can see my target line here on the map view. So it's, and we'll cover it in more detail, but it's a two-dimensional instrument, and we're really trying to use it here for three-dimensional drilling. Now, If you look at this target line, it's a line on my map view. And by default in your star steer, if you just go ahead and move your target line away from the lateral, it just follows the last survey azimuth of your horizontal wellbore. However, we understand that my well plan is turning here, so this is not my desired target line behavior on the map view. So if you're drilling such a complex lateral wells, make sure you select your target line, go to target line format, select the well plan that you have for this U-shaped lateral, and check this box, extend trajectory. And now, if you move your target line, this is what is happening. So basically, the target line is following the azimuth of your U-shaped lateral. So these are some introductory comments. So with that, I pass it to you, Daniel, so we can go on with the direction drilling part here.
Perfect. So there's a couple of things that I would like to cover as more sort of introductory points here, and I do apologise to any members of the audience here who I'm to each suck at eggs, but I think it's worth covering some of these basics. So the first thing is, as Igor says, target lines are, generally speaking, a 2D instrument. They are defined by a TVD and vertical section at the origin and the target, which defines a 2D line in space. This works absolutely fine. If the azimuth of the well you are drilling matches the vertical section azimuth entered in the well plan. So vertical section isn't actually a real value. It's a computed value. It's calculated from a specified vertical section azimuth and the north, south, and east, west coordinates of the survey. So while we're drilling a lateral which has an azimuth which is relatively close to our specified vertical section azimuth, the target line instrument, and as we use it right now, works absolutely fine. Now, as Igor has already shown, reality is at a complex well like this, or realistically any lateral which has any significant degree of azimuth change, vertical section really starts to fall down, and it's not really a very, very good instrument for geosteering or target line changes. In the extreme case, we would here have the vertical section azimuth specified as the direction of the landing point on this lateral. So in star steer, you can see this would be a direction and the target line is currently pointing. So while we're drilling ahead, it would look absolutely fine. However, as we go through that turn, even though we're moving forward in measured depth, when we're at 90 degrees or perpendicular to the vertical section azimuth, a vertical section plot won't change. We're effectively drilling into the page. So we can't actually visualize any changes at all, which is where the vertical section instrument really falls down. So in star steer, you could use the THL scale, which is a really good 2D representation of the wellbore. In Wells-Seeker, we would highly encourage people to use the 3D view. Or if you could possibly just open up the 3D view in Wells-Seeker.
Yeah, 1 second, please.
So you can see here, when you're drilling a complex lateral, really the tool of choice here is the 3D view. It's not to say that the 2D tools aren't useful, but they can lie to you, especially when going around a turn. So we would actively encourage users to more heavily rely on the 3D view when drilling wells like this. The second thing I want to explain is a little bit of terminology difference. The blue line you can see on the 3D view here is what we would call the well plan. Now, the well plan in the traditional sense is what has been signed off and approved by well planning for use by a directional company and approved by the operator. That is what we would traditionally use as the definition of well plan. However, when we create a target line, often we're going to create on-the-fly well plans. Now, we're going to refer to them in this webinar as well plans. The reality is these are not official signed off well plans. These are modifications of the existing well plan to represent the changes that we're going to have to make due to geosteering changes. So I'm going to use the terminology interchangeably, but target line change, well plan, the reality is it's whatever line the directional driller is actively trying to follow. Okay. The next thing I want to discuss as a sort of introductory point as well is distances. So when we are drilling a 2D lateral, okay, up, down, left, right, generally speaking, a good metrics for understanding whether you are in zone or how you are relative to your relative position to a well plan or target line. The issue is in a 3D well, a lot of the two-dimensional tools, once again, they start to break down. So if you are near the well plan in both left and right and up and down, then those metrics will work. If you are significantly left and right, if you've got any significant deviation left and right from the well plan, the up, down, left, right metrics really don't work as well as you would think, because once again it's becoming a 3D problem. So Igor, if you could just zoom in on the 3D view there. You can see here the 3D view is going to show you a much better representation of your proximity to the well plan. Okay, both left, right, and up, down. We do have the numeric values in the bottom left portion of the screen, which can be used. But once again, we do encourage the people to sanity check those numbers by looking at the 3D view and orientating yourself with the direction the well is currently being drilled. Okay, so I guess we'll start with the first geosteering change. So Igor, if you could click on the surveys tab and open up the Solo Cloud integration. Okay, so from the surveys pane, you go to the tools menu and click on Solo Cloud. Now you can see here that this is the integration. And this is what establishes the communication between the well seeker application and Starsteer. I do apologize, Igor. I'm going to kind of use Starsteer and Solo Cloud interchangeably here. I do understand they're separate products. So what you can see is you're going to be given a set of credentials by whoever the admin for Solo Cloud is, and you'll be given a username and password. You'll enter that in the credentials section on the Solo Cloud dialog. Once you've entered your credentials, you're going to be able to see the virtual projects in Solo Cloud. So for operators not wanting to allow the service companies to see every project within the Solo Cloud environment, that's okay. We're only going to be viewing the virtual projects. It also makes finding your project in Solo Cloud considerably easier. So you can see we've got three scenarios in Solo Cloud. We've got before the turn, mid-turn, and after the turn. So we're going to just be working here with this before the turn scenario. So as Igor said, normally we would set the auto update feature to true. You can see that over in the grid on the right-hand side. If we did this, every time a change was made to the target line, the directional driller would get a pop-up and he could accept the target line change. However, for the purpose is a demonstration, because we're not drilling this live, we're going to be keeping the app feature turned off, and we're going to be creating the well plans in a more manual sense, just for demonstration purposes. So you can see over in the Object Explorer tree, you've got access to the target lines, the formation tops, and the well plans. So or if you could just expand the target lines section, you'll see there are currently 3 target lines there. The one in green is the starred target line in Solo Cloud. Well Seeker is only watching for changes on the starred target line. So this is quite an important concept. So once a target line is starred, we're effectively watching it. So if you move it, you change it, we're going to get a notification that you have made a modification. So what we would recommend you do is, once a target line is starred, don't change it and don't iterate it as your working target line. We'd recommend you use a separate target line, make changes, and once you're happy with it and want it to be communicated to the directional driller, make that target line starred, and we will receive an update. Okay, so we're going to simulate creating a new well plan here. So, or if you could just click the Create Offset Plan button. And this would be done automatically whenever a directional driller accepts a target line in Well Seeker. Okay, so this is simulated us accepting the target line. So if you could just close that dialog, Igor, and if you have a little look in both the Star Steer and the Well Seeker Object Explorer, you can see there's a new well plan that has been created in both Well Seeker, and you'll also see that that same well plan has been pushed automatically to Star Steer. So there's a couple of points to note here. The first one is the name of the app plan. The well plan will always be named with the target line it was created from, and it's also going to have a UTC timestamp in it, which is going to indicate the time that that well plan was created. So this is our positive feedback loop. So basically automatically tell the Geosteerer, we have accepted and acknowledged the target line, and now this is the plan that we are following. You can see in the Well Seeker 3D view, we have a second well plan that has been created. Now, some of you may be a little bit confused as to why it looks like it's got this big step. That is absolutely deliberate. And the reason we do that is because whenever we are reporting our distances from the well plan, we want to know what EVD that is relative to at the survey point. If we were to use a more realistic, S-shape, smooth curve well plan, we would be reporting up, down, left, right distances, not relative to the TVD we actually want to be at. So the reason we use this step in Well Seeker is so as soon as we receive a target line change, our positions are relative to the plan that we want to be following. And so with that, I'm going to pass you back to Igor to talk about the Star Steer side.
Thank you, Dan. Yes. So we observe those changes in the new well plan happening in Well Seeker. Now let's quickly take a look at Star Steer. So some of you may notice that the new object just appeared in Star Steer once we synchronized with Well Seeker. And as Daniel said, this synchronization, yes, we pushed a button to make it happen. But if we enable this auto option, that will happen automatically every time you either modify your star target line or you star a new target line. So this is what is happening. Basically, we send, or let's say Well Seeker received this target line 1 automatically because it's starred. And it sent us back the new well plan, which is in red. So think of that as almost like a bank transaction, right? We send the money and we receive the confirmation that the money has been received. So this is exactly what happened. We received this red well plan that perfectly follows the target line. So we know for sure that the target line has been received by the directional driller and has been appropriately processed. So they see exactly what we see in StarSteer. And if we look into this well plan, and we'll discuss it a bit later as well, but it looks like it's curved. Well, this is because the entire wellbore is curving, right? So we are drilling right now in the up deep, and this is how we send our this is how we created our target line. But later on, as we turn, we'll be drilling down deep, because this is how the geometry works with this recommendation. So this is how it works in the this section pre-turn, and this is actually how it's going to work with any other well. So even if you don't have a U-shaped lateral, the same logic applies, right? So if you're just drilling straight ahead, you still can do this integration with the well seeker, and you will see those new well plans that are generated by the well seeker as a result of processing of the target line. So Daniel, if we're all good on this scenario, let's switch to the midterm, right?
Yep, absolutely.
Okay, awesome. So once again, we're kind of simulating the drilling here. Of course, in real life, it will be the same well, just new data is going to be added little by little. So let me just manually switch to mid-turn here. And what we have here, let me visualize it on the map view as well. Yes, so let's say we drilled ahead, and we are in this sort of in the middle of the U-turn. And we, again, it's a real data taken from Railroad Commission on the well that Chesapeake drilled in Eagle Ford. As expected from pure geological dips, right? We were drilling up deep, but now we are turning. So because we turn 90 degrees, we are generally expecting somewhat similar to 90 degrees formation dip. Interestingly enough, it's just my personal, geological observation. I looked at a few publicly available U-shaped laterals, and they all sort of have somewhat similar feature that during this turn, the gamma ray and the geological interpretation based on this gamma ray looks a little bit like erratic, like it's jumping up and down like it is doing here. I don't have a good explanation why it's happening, but I would say it's something to keep in mind. So as you are turning, your geology may look funny. So, but once, I mean, we'll take a look at it afterwards. But after the turn, it's all kind of coming back to the same, I would say formation dips that you were expecting as you were drilling towards the turn. So keep it in mind. And now I pass it to Daniel, so we can take a look. We can basically discuss what do we do and should we, introduce the changes during the turn.
Okay, thanks, Igor. So I'm just going to step back just a little bit here and talk about generally geosteering changes and azimuth changes. As we discussed, geosteering change is generally a 2D instrument, i.e. the azimuth that we receive the geosteering change as is what we are generally assuming the dip azimuth is. So if we're drilling here at an azimuth of about, I'm going to say at about 290 degrees, maybe 300 degrees, when we receive a target line change of saying a dip of 91 degrees, we're assuming that dip direction is in the direction of the azimuth that we are currently drilling, which is a very, very important concept. If we were to turn 90 degrees, so perpendicular to the azimuth which we received that at, we would basically assuming that at the dip at that point, regardless of which direction it was going, would be horizontal because it's a 2D plane, and we are now effectively drilling perpendicular to the 2D plane. If we turn a further 90 degrees, so 180 degrees total azimuth change from the direction we received the geosteering update, we would assume that the dip would be the inverse of what we received. So if we are drilling here at roughly 300 degrees azimuth at the dip of say 91, halfway through the turn, the well plan dip should be about 90 degrees, and once we complete the turn, the dip should be 89 degrees, so drilling down dip. So this is how we take a 2D instrument, which is target lines, and convert it into 3D. Now, what Wells Eco is doing, when it actually receives the target line change, it's doing quite a few things behind the scenes. What it uses is the current principal plan, so the plan which we are currently following. The left and right, i.e. the north-south coordinates, are assumed to be unchanged, i.e. we're still using the target line as a 2D instrument. So the north-south coordinates are interpolated from what the current principal plan is. The TVD is calculated continuously based on the amount of azimuth change seen since the target line was received. So I know that it sounds like there's quite a lot going on there, but really it's actually very, very simple. We're drawing a well plan that from a top-down view, so in the Starsteers map view, looks like it is following the U-zontal, and then if we look at it from a section view, we're actually adjusting a desired dip angle based on azimuth change, which is it's a pretty complicated thing to do behind the scenes, but as far as you, the user, goes, you have to do nothing. But it does bring up quite an important point. If you are going to issue a target line change mid-turn, it can have some fairly extreme results. So Igor, if in Wells Eco, we could switch to the mid-turn example.
Yes.
Okay, and let's go ahead, connect. We'll open it up in the 3D view, connect to Solo Cloud, and we'll pull the target line. And as Igor has mentioned before, this step here is purely for demonstration purposes. Normally, this would be all automatic. Okay, so we're just fetching those target lines from Solo Cloud. And once we actually get the connection and get the target line, we're going to create the offset plan again, just like we did before. Go.
Mm-hmm.
Okay, and now that we've created the offset plan, let's switch to the 3D view. Okay, so you can see what's happened here. We've received the target line change mid-turn. The process has been followed like we did in the first target line change, but with one interesting difference. We are no longer referencing the original well plan as our reference. We are referencing the previous stepped well plan as our reference. So you can actually see here in at the back of the 3D plot, we've got that original target line change that was issued pre-turn. Now you can see we have a second step in this well plan, which has got the new target line change issued. So effectively, the current well plan in Wells Eco gives you a history of all geosteering changes that have been made throughout the well. In this case here, we're going to demonstrate why it may be inadvisable to issue a target line change mid-turn. So Igor, or if you could just rotate the 3D view so we could see the end of the lateral. So you can see here that what's happened is it looks like we're now following what is really quite an extreme level of dip post-turn. And the reason that this has happened is because, as I said, we are assuming that the dip angle that we've received is in the direction that we are currently drilling. If you issue a target line change mid-turn, okay, we are only going to be drilling at dip for maybe a few feet because we're continually turning here. So the dip that we're going to be following is going to be continually adjusted. So the short version is, if possible, don't issue a target line change mid-turn. The slightly longer version is that if you have to issue a target line change mid-turn, that's okay, but we would highly recommend you issue a confirmation or an updated target line once the turn has been completed, so you don't get any of these potentially extreme changes in dip angle post-turn. One other point that's worth mentioning here as well, not only are we pulling the target line changes, we're also pulling the corridors. Igor, or could you just turn on the geosteering zones in WellSeeker?
Yes.
Right. So you can see here that we've actually got the corridor thickness is with which we've pulled from Starsteer along with the plan. One thing that's worth noting about the corridor is that you can make a change to the corridor without actually changing the well plan. So let's just say you're happy with the dip angle and the TVDs, but you want to change your corridor. That can be done, and that will register as a change in WellSeeker. WellSeeker is not going to create a new plan, but it is going to update the name of the current plan and push that back to Starsteer. So even though you're not going to be following a new well plan or target line as such, what you are going to get is confirmation that the corridor change that you have just made has been accepted. And you can check this by looking at the timestamp on the current well plan that's being followed. And with that, I'm going to pass it back to Igor.
Okay, yes, so we, as we all observed, we just received a new star target line here in the mid-turn, and this is how it looks in Starsteer. So as Daniel said, this is our first step, this is our first correction, this is our second mid-turn target line recommendation, which, as we all discussed, it's better to avoid unless it's some sort of an emergency and we really need to change it. But this is how it looks, and because we're in the middle of the turn, we are from kind of geological standpoint, when from azimuth of the drilling standpoint, we are in 90 degrees environment, so we're basically drilling flat. Once we provide this recommendation, going forward, it will be almost entirely flat. This is expected behavior because, we recommended to drill at 90 degrees. So yes, we will drill at 90 degrees. Now, again, the same logic as it was before. My resulting well plan that I'll receive from WellSeeker will have my target line name at the beginning and the timestamp at the end. So I can always see, how this well plan created, how it appeared, and basically how it looks, right? So what will be followed going forward. So with that, let me switch to the last portion of the lateral, so where we'll be simulating the drilling after the turn. So this is my after turn well, and again the same story. Let me switch it on the map view as well. The same story here. We have my after the turn. Blue is actual surveys, yellow is the well plan. I have my target line here, target line 5. And once again, we're looking at it from THL standpoint, right? So it's a curtain section. So if I'm to look in my vertical section, everything will, overlap on itself because the well is turning 180 degrees. So let's switch back to THL. Let's take a look at my target line. So yeah, I guess we are ready to send this recommendation to directional drillers. So Daniel, please go ahead.
Yeah, okay. Hey, so it's actually a reasonably good question that has been put into the chat, which is actually very relevant, which is talking about dogleg. Well Seeker interestingly doesn't really provide a suggestion to the directional driller as to how to get back to plan. So you can have a dogleg limit entered in Starsteer, but Igor, if you could just open up the Solo Cloud dialog here.
Oh, let me.
You need to be on the surveys. What you're going to see is on the right-hand grid, Igor, or if you could just scroll to the bottom of the top right-hand grid.
Mm-hmm.
Okay, what we can do is we can specify the transition and the dogleg that we are going to use on the well plan that we push back to Solo Cloud. Now, this is not necessarily the well plan that we are going to follow. Like I said, we are always going to use a stepped well plan. So we're not really enforcing any dogleg limitations at all, because that's entirely down to how the directional driller wants to accomplish his goal. He may not actually need to slide at all, because even though the target line has changed, he's still inside the corridor, and the rotary tendency might actually be bringing him back closer to the target line with no steering required at all. But one thing to note about the integration is we do have the option of pushing a smooth S-shaped profile plan back to Starsteer, which is probably going to be more realistic of what is actually done. But from a directional standpoint, we never use that S-shaped well plan because it means our distances will never, up, down, left, right distances, which we report, will never be correct, which is why we use the step. Now, it does bring up a couple of other interesting points as well. So there's the purely geological and geometric aspect about providing a target line change mid-turn. But there's also a very practical aspect as well, that while drilling the turn, the directional driller's earning his money at that point, okay? He's going to be working very hard to slide or use the rotary steerable to maintain left and right and maintain EVD. It's not to say that target line changes can't be followed mid-turn, but unless they're absolutely required, it's generally best to let a directional company work his way around the turn and make a change afterwards. Otherwise, you are just adding an additional level of complication to what he's already trying to do. The other thing that's worth bearing in mind while doing this during the turn is the type of assembly that you've got in the hole at the moment. If you're drilling the rotary steerable assembly, complex 3D geometry is much easier to drill. The rotary steerable tool itself is going to be able to hold both inclination and azimuth and making adjustments to the trajectory where the rotary steerable is considerably easier to do. The ability of a rotary steerable to steer isn't really affected by lateral length at all. The only thing that can be more challenging with the rotary steerable is the difficulty in sending downlinks the deeper you get. But in terms of its ability to steer, it's not really changed. If you're drilling with a conventional motor assembly, however, the further you drill in the lateral, the harder it is to slide. you are physically trying to balance a bent piece of pipe at 20,000 feet to push it in the E direction and you want it to go. Now, a good directional driller is able to do this, but the more change is you ask him to make, the further out in the lateral you go, generally speaking, the harder it is going to be to slide and make those changes. So the further out you go, likelihood is the longer it may take to affect those inclination and azimuth changes, which is certainly worth bearing in mind. Anyway, I do apologize, I slightly digress. So Igor, if we could move on to the post-turn scenario in WellSeeker.
Yes, give me a second. To Solar Cloud.
Yep, and let's go ahead and create it.
So select the target line, Daniel.
Yep, let's select the target line and let's go ahead and create the offset plan.
Yep.
Okay, so you can see we've just followed the same process again, but hopefully what this is going to show in the 3D view, the reason why it's very important to issue a target line change post-turn if you have issued one mid-turn. So now you can see in the 3D view, once again, step to target line, and you can see that that well plan now makes a lot more sense, shall we say. Igor, do you want to explain what's going on in the star steer side?
Yes, absolutely. So as we all observed, we decided to change the target line during the turn, which resulted in 90 degrees target line recommendation. Now, after the turn, we probably waited a little bit long and decided to change target line once again. So we sent a start target line to WellSeeker. So this is the resulting profile, the resulting let's call it set of recommendations to the directional driller. Again, we knew this is something that is going to happen, so we kind of simulated that case, which is not ideal. But once again, reemphasizing the fact that if we are changing target lines during the turn, which is not recommended but doable, make sure to modify to change it after you finish your turn or right before you finish the turn, because every time when your azimuth is changing, literally it's changing the way you're projecting your target lines ahead.
Just to add a couple of additional points here. One of the good things we've got here in ours, we've got full traceability in what geosteering changes were made, both in terms in WellSeeker here. You can see we now have 3 well plans, all with different timestamps. So you can see when the target line changes are received, what they were, and we can actually go back and look at that. You can plot as many of these plans as you want. You could, in theory, have all 3 of those target lines on. You could plot, and you can also plot these relative to any offset wells you have on the pad as well. In this example here, we don't have any offsets within the project. We just have well plans. But WellSeeker is able to plot, thousands of wells on the 3D view. And in the real world, you would want to do this specifically from an anti-collision standpoint. We're just showing this project here in isolation. Hopefully you can see while we've been doing this process, one of the sort of very much intangibles which you get with an integration like this is that the communication is now a lot simpler. Target line change is, from what I've seen in my experience, are communicated in a number of different means, either emails, WhatsApp groups, Teams chats, verbally. There's a lot of different ways that can be communicated, and a lot of them are often open to interpretation, because sometimes they're given a new to EVD reference to zero vertical section. Sometimes you're just given a new to EVD. This removes all of the ambiguity here. So hopefully from those of you on the directional side in the audience, you can see that a target line in StarSteer is literally just a 2D line in space. Okay, there's nothing more to it than that. What this integration does do, though, is it sees the desired, it projects that 2D target line in space and projects it back to where you currently are relative to that target line, and it's doing all of the maths behind the scenes for you. So it doesn't matter whether the TVD is referenced to zero vertical section, anything like that. It's taking away all the ambiguity. So hopefully it should massively reduce the amount of fat fingering you get from entering incorrect TVDs and dips, and also remove a lot of confusion with TVDs referenced to zero vertical section. Hey, Igor, I guess we can go to our conclusions.
Yeah, I think we kind of started them, but yeah, go ahead, Daniel.
Yeah, so we've really got, you know, 4 main conclusions here. The first one, and the biggest one, I would say, is, if possible, avoid target line changes during a turn. Right, easy is that. If you don't have to, don't do it. That's from both the geological standpoint and the practical aspect that the DD is trying to steer a turn. The second thing that's worth bearing in mind is the ability for a directional driller to execute a turn does depend, a target line change does depend on the type of assembly he has in the ground, motors versus RSS. As I mentioned before, the direct integration between Wells Pro and StarSteer really closes the loop. And Igor, as an analogy, bank transactions is very, very apt, is very, very good. We can now positively verify that the directional company has acknowledged and received the new target line, and the Geosteerer can confirm that the change he has received is correct, and it interpretation. And the last real conclusion is the techniques that we've demonstrated today, they are absolutely applicable to far simpler wells with turn in the rather than a complex U-zontal well. It doesn't necessarily have to have as much extreme turn. What we've shown today would be applicable to a well that's got 40 or 50 degrees worth of turn.
Yeah, I guess, and if you have any questions, so I'm sure lots of you will have some, follow-up questions, how we can, on your side, how we can have WellSeeker and StarSteer connected. Make sure to contact us or INNOVA. So the emails you can see at the bottom of your screen. We'll be happy to help you. It's easy to set up. The data is there. Most of the directional drilling companies using INNOVA. Most of the companies that perform in geosteering using StarSteer and Solar Cloud. So it's just a matter of two software packages getting connected, which is quite easy to do, as we demonstrated to you today. I guess with that, Daniel, we finished the talking part and switch to questions, right?
Yeah, that's right.
Okay. I will take kind of star steer / geology questions. So the first one we had was from Stanley. Can you explain why grids may project differently in THL versus VS? So this is actually a very good question. Let me exit this presentation mode here and switch back to star steer. So, and maybe switch back to the case where we had before the turn. So the well just landed. And and let me turn off the, for simplicity, let me turn off my interpretation extension. So this dashed line here at the very top is my structural map, my grid. And you can kind of see it follows the U-shaped lateral because I'm projecting it in my extension of the grid is slicing through the well plan, which is something we strongly recommend to do when you drill such a complex 3D shaped laterals. And the way you can change it in star steer, you can just adjust your well plan to 1 second. So this is my well plan. Yes. So my well plan is used as grid / seismic slice here. So if I'm slicing my grid through just regular well, which just landed, my grid will look like this. In fact, you see that because my grid, if I visualize it here, it is very small. Give me just 1 second to visualize it. Yes, so it ends right at the turn. So technically, if I'm using just my existing surveys, my existing lateral to slice the grid, it just slices it according to the last survey point azimuth. So we strongly recommend, if you have any kind of complex 3-dimensional trajectory, not necessarily U-shaped, but generally 3-dimensional trajectory, you go to your well plan and use it as a grid and seismic slice. So you see it kind of changes the way it's slicing here. So this is the difference, and this is how we recommend doing it. Comment from Colleen, funny geology in the turn. It may be because of increased survey uncertainty, survey error that comes with more sliding. I probably agree with that. I think we just consistently see that type of funny geology in the turn. So yes, it's not geology. It's something related to the way we take those surveys. So yeah, I think I agree with that. Aline is asking, we can observe that the new target well plan is starting from the original plan rather than starting from ICP landing bit projection. That is how the wells, I guess, Well Seeker Pro works. I guess, Daniel, if you want to take this question.
Yeah, absolutely. Yeah, that is exactly how Eco Pro works. We're actually taking the offset based off the well plan rather than the bit projection, because the well plan is the line that the directional driller is trying to follow. The actual new well plan that is being created is having that stepped profile up to the TVD specified by the target line. So really where that plan ties onto almost doesn't really matter. We tie onto what the current well plan is, so that we have that sort of traceability, that audit of what the well plans, what the well plan changes were.
Okay, next question from Randy. So always maintaining true deep. I guess it's if I understood this question correctly, it's maintaining true 3-dimensional deep, which will have a component of deep and azimuth. So I guess technically that would be an ideal case, that we just have a true 3-dimensional deep as an input. However, I think we are working in kind of real world here, where we prefer to deal with somewhat consistent workflow, where we just provide target lines from the cross sections. And with that workflow, yes, we have the biggest pitfall we have is that turn section. In case if we provide a true three-dimensional deep, that problem with the turn section wouldn't happen. However, that would substantially overcomplicate the workflow. So long story short, as long as you're not introducing any substantial changes in the turn, you should be good with the current workflow. You can feel free to change your target line as you drill the first portion or before the U-turn and right after the U-turn. That's good enough, and that should work perfectly well. I guess next question, Daniel, is for you.
Yeah, I think I briefly touched on this in the talk, but in terms of honoring a dogleg limitation, no, WellSeeker doesn't honor a dogleg limitation. It will use the dogleg limitation specified to send back that pseudo S-shaped well plan back to Starsteer if specified. But in terms of the actual well plan which we create, WellSeeker always creates that step, which has got massively artificial dog legs of tens of thousands to create that step. In terms of the actual dogleg limitation the directional driller uses, generally speaking, that's going to be down to a directional driller there's going to be down to the directional driller / company man as to what they want to specify as a true dogleg limitation. With rotary steerable, it's much easier to stay within those limitations. But if a motor, especially deep into lateral, sometimes it's a little less predictable.
Okay. I guess the next one, Daniel, is also for you, but you may address it already.
Is this the follow-up complex issue for an active well?
No. Does WellSeeker allow you to plot offset and previously drilled lateral?
Yes, it does.
Okay.
Here's the short version.
Another question, will we get access to the recording? Yes, the recording will be posted on ROGII and INNOVA's YouTube channels. So you'll be able to see it, and it will be in full HD, so better quality than you can see on your screen right now. Full screen on Starsteer. Yeah, I realized that because we are showing two software at the same time, you may not be able to see everything. Once again, the recording, if you would like to go to a specific screenshot, Chris, you can open the YouTube video. It should be in better quality, so you can zoom in on a specific part and see which buttons we were clicking. Yeah. Daniel, I'm not sure you want to take the one from Aline or
yeah, I can kind of take this one. This is a point which I sort of alluded to at the start of the presentation. Basically, one of the problems is that to issue a true verified well plan, an approved well plan, is not a quick process. Certainly not quick enough from a geosteering standpoint. So to create an official approved well plan for a directional driller to follow or a target line change just isn't always practical. Reality is we are storing the current as approved well plan in WellSeeker, which can be referenced. But as soon as a geosteering update has been given, we really want to be referencing our position relative to the desired TVD specified by geology rather than what the actual issued well plan was. But yeah, so hopefully either that clears things up.
Awesome. Last one, comment from Michael from ADNOC. Probably Michael left us already, but it's generally exciting to see that somebody stayed so late, and because ADNOC is a company from Arab Emirates, stayed so late to see this webinar live. So yeah, we'll have a recording and we'll post the recording on both of the YouTube channels. I guess we're done with the questions. So once again, thank you for joining. Very well attended webinar. Lots of great questions, discussions. Any questions? Let me bring back this slide with the emails. Any questions? Please feel free to reach us out, and we'll be happy to answer those questions or to set up the connection. Daniel?
Yep. No, thank you very much for attending. Just reiterating what Igor said, as any questions at all, please feel free to reach out. We'd be happy to help clarify and get users set up with the integration.
Awesome. Thanks a lot. So have a good day, have a good evening, have a good afternoon.
Thank you, guys.